Herd immunity. All right, let's talk about a concept that went from being tucked away in medical journals to being talked about at dinner tables all over the world. But what does it actually mean? Let's dive in and really unpack one of the most important and, one of the most misunderstood ideas in all of public health.
I mean, especially during the COVID-19 pandemic, right? The phrase herd immunity was everywhere. It felt like it was on the news every single day. It was this finish line we were all supposed to be aiming for. The point where life could finally get back to normal.
But here's the thing. The more popular the term got, the more confusing it seemed to get. For some people, it was just a number, a simple percentage. For others, it was this really complex biological state. And all that confusion led to some pretty intense debates. The phrase itself became a total flashpoint, both politically and scientifically.
So, to get to the bottom of it, we've got to cut through all that noise and ask some really basic questions. What does the science actually say, and what's the real story behind this powerful idea? That's exactly what we're going to explore.
You know what's so wild about this whole debate is how you can have experts who sound like they're saying completely opposite things. You've got the World Health Organization saying that trying to get there through natural infection is unethical. But then you have the Cleveland Clinic calling it powerful and life-saving. So, who's right? Well, the crazy thing is, they both are. The whole thing, the entire controversy, hinges on one crucial detail: how you achieve it.
Okay, so let's start with a solid basic definition. At its core, herd immunity, you'll also hear it called community immunity, is actually a pretty straightforward idea. When enough people in a community are immune to a disease, it's like building a protective wall. The virus or bacteria just can't find enough new people to infect, so the chain of transmission gets broken and just fizzles out. And that protects the people who aren't immune too.
But to really get a handle on this concept, we have to go back in time. And you might be surprised to find out that the idea of herd immunity didn't start with people at all. Nope. It started with livestock.
The journey this idea took is just fascinating. So check this out. The first time anyone even used the phrase was way back in 1894. It was a vet named David Salmon, and he was talking about nutrition for hogs. But the idea really started to take shape in 1916 when another vet, George Potter, used it to talk about stopping disease in cattle. From there, it jumped over to lab mice in Britain, and then finally, in 1924, a guy named Sheldon Dudley applied it to what he called the human herd while he was studying a diphtheria outbreak at a school.
Back in 1918, Potter used this absolutely brilliant analogy that still perfectly explains the concept. He said, a disease is like a fire, and people who can get sick are its fuel. So if you take away the fuel by making sure most of your herd is made up of immune animals, the fire just runs out of stuff to burn. It dies out. That simple, intuitive idea is really the heart and soul of herd immunity.
But a good analogy isn't enough to build public health policy on. To make this concept really useful, scientists needed a way to turn it into a number, a clear target they could aim for. And this, my friends, is where the math comes in.
The entire calculation really boils down to one critical number: R0, or R0. It's basically a measure of how contagious a disease is. So if a disease has an R0 of 3, that means one sick person, on average, is going to infect 3 other people. But that's in a population where absolutely nobody has any immunity yet.
And once you have that R0 number, you can plug it into this really elegant little formula to figure out the herd immunity threshold, or HIT. It tells you the exact percentage of a population that needs to be immune to stop an outbreak dead in its tracks. The whole goal is to push the effective spread of the virus below 1, so each new case leads to less than 1 new case after it, and the disease just fades away. And you can see how this works with different diseases. For polio, with its R0 of around 5 to 7, you need about 80% of people to be immune. The original strain of COVID-19, that needed somewhere in the neighborhood of 60 to 67%. But then, you get to measles. Look at that R0. It can be as high as 18. It is so incredibly contagious that you need almost everybody, we're talking 95% of the community, to be immune just to keep it from spreading like wildfire.
Okay, so that formula is a great guide. But, and there's always a but, right? The real world is never that simple. That threshold is a model, and in reality, there are a bunch of other factors that can make things a lot more complicated.
So here's a really important one. We don't all mix with each other randomly like molecules in a gas. The classic model kind of assumes that, but it's not how we live. Some of us are super social, and others are more isolated. A fascinating study in the journal Science showed that when you account for this, you can actually lower the herd immunity threshold. In their model, it dropped from 60% all the way down to about 43%. Why?
Because if you can immunize the most socially active people, the so-called superspreaders, you're basically removing the biggest engines of transmission. And that has this huge, outsized effect on slowing everything down.
And there's another major real-world factor. No vaccine is 100% perfect. So to deal with that, scientists just tweaked the formula a little bit. The vaccination level you actually need is the herd immunity threshold divided by how effective the vaccine is. So if a vaccine is only, say, 90% effective, you've got to vaccinate a larger percentage of the population to get that same protective shield for the whole community.
So when you pull it all together, the history, the math, the real world's complexities, you really start to see why this isn't just some abstract idea. It's a true cornerstone of modern public health strategy.
And the benefits are just profound. Herd immunity is what shields the most vulnerable people among us. Brand new babies who are too young for their shots, cancer patients whose immune systems are weak, the elderly. It prevents an incredible amount of suffering and death. And in some of the greatest triumphs of public health, it's allowed us to completely eliminate diseases from entire regions and, in the amazing case of smallpox, to eradicate a disease from the face of the earth.
And that kind of leaves us with one final big thought to chew on. The science of herd immunity is about more than just biology and math. It's this stark, powerful reminder that when it comes to public health, we're not just a collection of individuals. Our choices, our immunity, our risks, they're all connected. It shows us, in the clearest way possible, that the health of one really does depend on the health of us all.